Adipose tissue plays a central role in regulating energy balance not just through storing and releasing calories, but by actively communicating with the brain to influence appetite, satiety, and overall energy expenditure. One of the most compelling examples of this sophisticated endocrine dialogue is leptin, a hormone produced almost exclusively by adipocytes. Leptin fundamentally changes the way we understand fat, not as a passive burden, but as an active organ that speaks directly to the hypothalamus, the brain's metabolic command center. This communication is essential for maintaining body weight, nutrient balance, and long-term metabolic stability. Leptin secretion is proportional to fat mass. As adipose tissue accumulates during periods of energy surplus, leptin levels rise and travel through the bloodstream to the brain. There, in the hypothalamus, particularly the arcuate nucleus, leptin binds to specific receptors on neurons that regulate hunger and satiety. The result is a suppression of appetite and a stimulation of energy expenditure. This feedback mechanism is elegant. More stored energy leads to stronger signals to reduce intake and increase caloric burn. It helps prevent overeating and maintains weight within a stable range over time. Conversely, when fat stores are depleted, such as during fasting, prolonged calorie restriction, or starvation, leptin levels drop sharply. This reduction is interpreted by the brain as an energy deficit, triggering intense hunger, reduced thermogenesis, and a slowdown in metabolism to conserve fuel. These responses are not just reactive but preemptive survival strategies. In evolutionary terms, leptin acts as a nutrient-sensing hormone that helps organisms survive periods of feast and famine by tightly regulating the drive to eat and the efficiency of energy use. This homeostatic loop highlights how essential healthy adipose tissue is, not only as an energy reserve, but as a control node for behavioral and physiological responses. In fact, when leptin signaling is absent or impaired, severe metabolic dysregulation results. Children born with congenital leptin deficiency exhibit insatiable hunger and extreme early-onset obesity. But when treated with leptin replacement therapy, their appetite normalizes and weight gain reverses, demonstrating how powerful and indispensable this single adipokine can be. However, in the context of common obesity, the story becomes more complex. Most individuals with excess fat mass have high circulating leptin levels but continue to experience hunger and gain weight, a condition known as leptin resistance. In this state, the hypothalamus becomes less responsive to leptin signal, blunting its appetite-suppressing effects. But even this dysfunction should not be seen as a failure of adipocytes. Rather, it reflects a broader systemic challenge. Inflammation, nutrient overload, and disrupted insulin signaling may impair leptin sensitivity in the brain. The fat cells are still producing leptin appropriately. The issue lies in how the signal is processed. Leptin's influence extends beyond appetite regulation. It plays roles in reproductive health, immune function, and thermoregulation. Leptin receptors are found in multiple tissues, and the hormone modulates bone formation, supports thyroid hormone activation, and affects T-cell activity. These widespread effects further affirm that adipose tissue is not isolated to metabolism, but deeply integrated into all aspects of physiological regulation. Understanding this multidimensional role of leptin reshapes how we view fat. Adipose tissue isn't a liability. It's a vital informant, constantly updating the brain about the body's energy status and helping to calibrate behavior and metabolism accordingly. Even the challenges of leptin resistance and obesity highlight the system's foundational importance. When it fails, the consequences are severe, and when it functions, the benefits are profound. Supporting leptin sensitivity through reducing inflammation, improving sleep, increasing physical activity, and promoting metabolic flexibility could be a key therapeutic strategy in restoring proper energy balance and preventing chronic disease. Thus, healthy fat is not the enemy of health, but one of its greatest allies. Through leptin and other signals, adipocytes help the body self-regulate in a world of abundant food and fluctuating demands. Recognizing and preserving this regulatory capacity may be one of the most important steps we can take toward long-term metabolic well-being.